In this segment, we're going to discuss reflexes. Reflexes are an example of local processing that occurs in the spinal cord itself. They're influenced by the brain, but it doesn't need your brain's permission. Okay, so when you have a reflex, definitely influencing from higher influences of the brain and higher centers are going to have an impact on how brisk or dull that reflex is, but it doesn't need your brain's permission to go. And as the sensory information that you have participated in a reflex will be related to your brain, but it's just a wee bit delayed so that your brain gets the information. But again, it doesn't need your permission you don't need your brain's permission to undergo a reflex. So what do you need to have a reflex? Well, first you need a receptor, something in your skin, your muscle, a joint, or even the viscera, and we'll talk more about those visceral reflexes in the autonomic section, but you need some sort of a receptor. Then you need that neuron, that dorsal root ganglion neuron that is the sensory that receptor is attached to. Sometimes you'll use an interneuron in the spinal cord and sometimes you won't. So interneurons are usually there. This is what distinguishes a polysynaptic, i.e. more than one synapse, from a mono, i.e. one synapse reflex. And we'll talk about the difference between the two. You need an efferent motor fiber, so that's the axon of the motor neuron that's going to cause the movement part of the reflex. And then you need some kind of an effector, and that is going to be the muscle. And that can be striated or smooth, depending on whether this is somatic or visceral, or even it could be a gland. And so here's how the basic workings of a reflex. So out here in the periphery, there will be some sort of noxious stimulus. And this could be stimulus. And this could be anything from stepping on a sharp stone or picking up something that's too hot. And the receptors for that are going to be in the skin. So these are the peripheral processes of these dorsal root ganglion neurons that live here in the dorsal root. So the dorsal root ganglion neuron then relays this information into the dorsal horn, and then it's going to synapse on an interneuron. The interneuron then is going to synapse on a great big motor neuron here. And the motor neuron then exits through the ventral root and then synapses on the muscle and causes it to contract. So this is the basic setup of your polysynaptic reflexes. It's also called the pain reflex or the flexor reflex, because mostly it's going to be pulling your body, pulling your limbs or extremities in towards your body away from the noxious stimulus. So noxious stimulus, nerve endings in the skin that are picking up that stimulus, going through the process of the DRG neuron, which lives here. The DRG neuron then carries that information into the spinal cord gray in the dorsal horn, synapses on an interneuron here. The interneuron synapses on a motor neuron in the ventral horn, which then sends its axon out through the ventral roots into the spinal nerve, which then innervates a muscle that then moves this piece of skin away from that noxious stimulus, be it like a sharp stone or fire or something equally damaging. In the next slide, we're going to talk about monosynaptic reflexes. Monosynaptic reflexes are special, and these guys are usually monosynaptic reflexes usually refer to the tendon reflex. So the tendon reflex, you've probably had this happen whenever you go to the doctor and they come at you with that rubber hammer, okay? And they're hitting you on your patellar tendon, which is in your knee. Sometimes they can test tendons of other muscle groups. If you look at the demo that Nico and Christina did. Nico has described some of the ways that they test for reflexes, tendon reflexes. This is a monosynaptic reflex. There's a special receptor called a muscle spindle that lines up with the rest of your skeletal muscle. When this is stimulated, the nerve endings, of course, have their cell body in the dorsal root ganglion. They come into the dorsal horn and they directly synapse on a motor neuron. The motor neuron then sends its axon out the ventral root to the muscle. This is why it's monosynaptic. There's no interneuron here. The way that this works, I drew this coil. So this represents the muscle spindle. The distance between these coils, so if it's very tightly coiled, like this, it's sending one kind of a signal. If it's loosely coiled, like this, it sends another type of the signal. And the difference between the space within the loops of the coil are what activate this sensory neuron. When it's activated, then it directly synapses on a motor neuron, which directly synapses on the muscle to cause the reflex. So you have two types of reflexes: pain or flexor reflexes, which is a polysynaptic and it uses an interneuron. And then we have the monosynaptic reflex, which is the tendon reflex, which doesn't use an interneuron and just has the two neurons in the chain. So to summarize, what I want you to know is I need you to be able to define a reflex and what are the components, what are all the different cellular neuronal components that you need to have a reflex. What's the difference between a mono and a polysynaptic reflex? And then how is your brain involved in reflexes? Or how is your brain not involved in reflexes? If you know all of these kinds of things, then you're ready for the assessment.